We're ready to go. Good morning, everybody. How's everybody doing? How many people this is their first Ignite? Oh, wow. I hope the conference is going well for you guys. I look forward to seeing you at the celebration this evening. My name's Yatharth Gupta. I'm the Group Product Manager for Azure Databricks. How many people have heard of Azure Databricks? All right, that's good. How many people have not heard of Azure Databricks? I see one over there and maybe one over there. All right, so we have a little bit of something for everybody. Here's what we're going to do today. And we're going to leave some time for Q&A. Just like walking through the room, there were a lot of questions, so we're going to leave some time for Q&A. But we're going to talk about what is Databricks, just to ground everybody on what the service is, how we think about it. I'm sure you guys have all used it, but how do we think about Databricks, and what are the things that we aspire to do with this service? We're going to spend some time looking at different use cases in different industries. So, one of the things, if you've used Databricks, and if you're like me, if you're an engineer, you look at Databricks and you say it's Spark. But I love to show some of the use cases that we've seen customers use this in. And my goal is, hopefully, at least 90% of you resonate with one of those use cases that you're either already doing or you can take back home, or it's something that you can invest in. And then we'll deep dive into the best practices. Best practices is something we care very, very deeply about. The interesting part about best practices is most of these are learnings from you. These are pieces of feedback that customers have given us when they've gone through excruciating pain, or when we have gone through excruciating pain. And we want to make sure that nobody else has to do that. So we learn from those. This is a continuous learning cycle for us. And we'll share some of those best practices. We'll quickly flash the roadmap. I won't spend a whole lot of time going into the roadmap, but we'll leave it up there if anybody has questions, or if anybody likes a feature that they see over there, or more importantly, don't see. We're going to stick around here. I've got a couple of folks from the team, so we're going to stick around here. We're going to try to take as many of your questions as we can until they kick us out, and then we'll take them outside the room. Sounds like a plan? So, we bought the Databricks service. Databricks is an independent company from San Francisco. It's founded by the guys who actually founded Spark at AmpLab Berkeley. And when we looked at this service, we saw a market need for Spark, and this was a great cloud-born service. So on March 22nd, 2018, that's a year and a few months, about a year and a half back, we launched the service on Azure. Our goal with this service is to make sure that you have an environment, a Spark environment, an analytics experience, where the DevOps costs are minimized. One of our biggest goals is to continuously increase your productivity. There are things that we have seen that every customer has to do. And we believe, to the extent possible, that if it's something that every single customer is doing, then they shouldn't have to do it. If every single customer is trying to figure out how to scale up and scale down their cluster, then that's something that we should be doing. If every customer is thinking about other problems that we've identified, we should be fixing that. And that's one of our biggest goals. And there are lots of different metrics we use, mostly subjective metrics at this point, to track some of these things. We made sure that this service is built on a secure and trusted cloud. Security and trust is something that's very important to Microsoft. And when we bought Azure Databricks over, we made sure that we tightened and strengthened all the security controls that we knew about. We're continuously adding more compliances. We're continuously focusing on enterprise networking and security features. So that's a big deal for us, and we want to make sure that that's the experience we deliver to you through this service. And then it's built on a cloud with no limits. I mean, there is obviously some limits to everything, but we want to build a solution where those limits are, to the extent possible, not visible to you. So that's sort of how we think about Azure Databricks. The other thing with Azure Databricks is, when we launched this, we launched it in 6 regions. And we quickly realized that the service is uninteresting to you unless it is in a region close to you. And for those companies that are global, it is uninteresting to you if it's not in a region where one of your offices are. So we have put in a lot of effort into this, and we are today in 29 regions. As you can see from the list, we are in the US, we are in Europe, we are in Asia, we're in Australia, we are in South America, and Middle East and Africa. We're not done. This is just the beginning. The rapid pace of growth has shown us that we need to add 2 or 3 regions every quarter. So our goal is in the next next year or so to be in every Azure region, and every new region that launches, we're going to be there very quickly right after it launches. So that's where we aim to go. And what is super valuable to us as we discuss some of these things is either now, after the meeting, either you can ask a question or tell us personally, like if you feel that there is a strategic region where we are not in, we'd love to hear that feedback. We do a lot of research, try to collect this information, but it's great to hear directly from people. What are customers doing with this service? So there's a couple of different pivots. There's a couple of different ways to look at it, because what we have found is when we talk to the technical decision maker or the business decision maker, there are a few people who come and use Spark. Like, of course, they're using Spark, but that is not their goal. They're trying to solve some problems. And we take these problems and we bucket them into sort of 3 categories. And we'll go over a little bit of architecture in the next slide, but the first problem that customers are solving is they are doing BI analytics at the end. That's what we call a modern data warehouse. You're getting data maybe from disparate sources, you're putting the data together, you're doing some analysis in Azure Databricks. You might then be pushing it directly to Power BI, or you might be going through a data warehouse or a SQL DB, but your end goal is BI. That's where your data becomes intelligence, is at the BI layer. The second set of scenarios is where customers do the exact same thing, but their end goal is not BI. Their end goal is to power a line of business app. So think about a website that has a recommendation engine. Those recommendations are being generated in some tool over massive amounts of data and being stored in an operational database. So that's another pattern where customers use this. And the third one is real-time analytics. And the popularity of this has significantly grown even since the time we launched this service, where customers are looking at batch data, but they're also looking at real-time streaming data. And we have a lot of functionality built into Azure Databricks. We, in fact, have a whole team that focuses on just streaming scenarios and making sure that they are continuously improved and up to date and match the needs of what our customers want. So these are 3 things that customers typically do with the service. Let me ask a question, because I feel like I see some people getting bored. So how many of you feel that your scenario fits into one of these, where you're doing BI? Let me just see the BI hands. And that are ending the data in a line of business app? Okay, that's much fewer. And real-time streaming? None of the above. All right, we're going to talk to the none of the above people after the meeting. Please come see us. But when you put this together, right, like at the end of the day, you come to Azure, you're not coming to Azure to just use Azure Databricks. You are coming to build a solution that solves a business problem that you have. We have several services that, depending upon your needs, partake in building this solution. The first part is getting data. So if you're getting batch data, we have Azure Data Factory, where you can get batch data from, I believe, 72 sources, and they keep adding more and more sources. That's one way of getting data. You have data in SAP, you have data in other sources. Maybe you have data in AWS that you want to move to us, and please text me if you want to do that. I'll help you. So Azure Data Factory helps move that data. At the same time, if you have streaming data, that comes in through an event bus, such as Event Hub or IoT Hub. We also support Kafka. We support Kafka in HDI. We support Kafka that's in Event Hub as part of a PaaS service. So all of those methods are supported. Once you get this data, if you have batch data, you want to store it somewhere. And this is important. Like we think of, sometimes storage is just a place to keep data, but you want to have governance around that data. You want to have ACLs around that data. You want to have audit trails around who use that data. And we have a solution called Azure Data Lake Store or Azure Blob Storage. Depending upon your need, you pick the right one and store your data in there. Once your data is stored, you do analysis in Azure Databricks. This is where you run your Spark queries. A lot of people run ETL. A lot of people run ML jobs. This is what you do in Azure Databricks. And then the roads fork. You can either go to an operational database such as Cosmos DB or SQL DB. If you're running an LOB app, it's typically powered by an operational database. It's unlikely that you're going to plug in the LOB app into Azure Databricks. If you're doing that, again, let us know. That's maybe not a good best practice. Or you might be deploying a model, which you might do in Kubernetes. So maybe your output was a machine learning model that you want to deploy and constantly score against. You might do that in Kubernetes using AML. And the scenario downstairs is you can go to Power BI. You can do this through Synapse, which I got a lot of questions at the beginning about. Happy to take those at the end. But Synapse, one part of Synapse is a data warehouse, and we have connectivity to that data warehouse from Azure Databricks. So that's sort of what an architecture generally looks like. We feel that customers sometimes replace this, like instead of ADF, they might use NiFi in some cases. They might use Tableau instead of Power BI, at least the customers who come to me because they're at least using Databricks, but the general pattern is pretty common. And we actually recommend this pattern. If you're building an analytics solution using Azure Databricks, this is the pattern that we would, if you came and spoke to us, we would start with. And we're, again, constantly open to feedback, learning from what you guys are doing. This is the architecture stuff, but if you look at where this is being used, and when we started this, I have to be honest about this, at least when I started on day one, I birthed the service in Azure, and I did market evaluation, and I had like maybe 5 industries, but what we've seen is like we've seen adoption, massive adoption in financial services. Some of that took a while to get started, but once it gets started, there's massive adoption in financial services. Retail, we have big retail customers using Azure Databricks. Automotive and IoT, especially for the streaming scenarios, is getting very, very interesting. A lot of new innovation happening, especially in the Europe sector in automotive and IoT. Advertisement and marketing, so there are big marketing cloud companies who are using us to deliver part of their solution. Health and life sciences, we're just getting started on this. As the year goes, you'll see more and more announcements around genomics. I won't pre-promise anything, but that is our goal. Before 12 months from now, you should hear a lot more about genomics from us. Entertainment, media, and gaming, I put that as a broad category, but entertainment, where people are building recommendations, and gaming, where, again, they're doing sentiment analysis, recommendation engines are being powered by Azure Databricks. Security and threat prevention, this is another one we've seen. Security logs are massive amounts of data. And when you have to process them, build machine learning models, come to sort of hypothesis, a lot of people are using Azure Databricks to deliver that. And then industrial IoT. This is a pretty traditional use case. Industrial IoT sensors generate data. You get that data. You analyze that data. You generate some output from it. I'll walk through a few use cases here. I'm just going to check how I'm doing on time. But some of these, I won't walk through every one of them. You guys will all have the slides if you want them, so they're all in there. But customer analytics, again, in the finance industry, if you look at consumer finance business, we all, I presume, have credit cards, and we all get these offers mailed to us, but they're not really that good. They're not targeted. Some of the things that consumer financial institutions are doing is that they're taking all of the data that they have about you and profiling that data to generate better, more optimal offers for you. So they can send you products or give you discounts that you actually care about, not just spray and pray emails. So that's one of the areas where this is being used. Predictive analytics is another one where we see a lot of use cases. Sorry, my slides. Where we have customers who are running predictions on what-if scenarios, what will happen. So a lot of use cases over there. Similarly, in the marketing cloud, I spoke a little bit about marketing cloud, but sentiment analysis, like imagine if this room had 4,000 people listening to me. How valuable would it be that every time I progressed a slide, I could get the sentiment, whether you were tweeting about me or whether you were giving me a score or posting something on Facebook. If I could take all of that data and generate that sentiment, that's something that marketing cloud vendors are doing on Azure Databricks with batch streaming, real-time streaming, and a lot of the innovations that we've built in. And then we have IoT, where people are doing supply chain optimizations. That's the one use case I'm highlighting here, where people are doing supply chain optimizations with Azure Databricks. This cool story, like I met this customer in Australia. The customer won't let me use their name, but their goal, or at least their vision, is to reduce food waste and hence make more money, but to reduce food waste. So what they do is they have little sensors in each of the trucks that their transportation company brings in, and they measure temperature, humidity, a bunch of other things. They also have external data, such as the weather in Australia at different places and the traffic. And they figure out through these algorithms on where to put the crate. So they know which food is going to expire the soonest, not just because when it was harvested, but also because what conditions it's been through. And they take all of that data and they make sure that they reduce food waste, so they're doing something good for the environment. They're also saving a lot of money with it. So these are the use cases that are the most interesting for me. I'm going to, in the interest of time, I'm going to skip this. We'll come to my fun slide. So this is the fun slide. This is the slide that humbles me the most. Last time I was here about the same date, I think Ignite might have been a little bit later last year, and I stood up on stage and I spoke about 300% growth, and I was blown away that we could grow 300% for a service that we launched just the year. Today, we're 7,000% bigger than we were last time, so in 1 year. And this is why best practices are important. What we have seen, both with our customers and with us, is the product that we have built, while there are always concerns and issues, the product is usable that once the customer starts to go, they scale up very quickly. And sometimes we never focus on the best practices, and then things go bad. This is just one customer, just to give you an idea. This is how fast one customer grew. You can see how many clusters they were running and how many clusters they ended up in just a few months. So that's my lead into best practices. Enough of overall overview pitches, but this is something that we observe again and again, that we have customers who have issues, they solve those issues, and then they grow really, really fast. And if they don't have a good foundation, then things go really, really wrong. What we're going to do today is very simple. We're going to look at 2 viewpoints and very few recommendations. One viewpoint is the IT administrator viewpoint. The other viewpoint is the developer viewpoint. Like if you're building a Spark application, what are the things you care about? And if you're an IT, somebody who's administrating the service, what do you care about? How many people fall into I do some or all of the administration? And how many people fall into I only build Spark applications? All right, somebody's got to give me, what about the rest? Sorry? Project managers. OK, great. So we'll start with some best practices for networking, security, and capacity planning. Let's start with the core concept. And I'm going to ask a couple of questions, show of hands. How many people know what an AAD tenant is, an Azure Active Directory tenant? How many people know or have an Azure subscription? OK. So an AAD tenant is sometimes also called a directory. This is just a very foundational concept that in Azure, you have an account that your company has. They have an enterprise agreement or an Azure account associated with it. In that account, you might have one or more tenants. Our larger customers typically have a prod tenant and a pre-prod tenant because they want to keep clean separation. That's a very good best practice, but a lot of our customers just have one tenant. If you also use Microsoft Office, the easy way to identify a tenant is it usually has your email address associated with it. So like @Microsoft.com would be one tenant in Azure. Inside a tenant, you can have one or many subscriptions. Inside each subscription, you can have one or many workspaces. As you see on the left-hand side, you see 2 workspaces. You see 1 workspace in subscription 2 and 3. And inside a workspace, you can have many, many clusters. So with this foundational concept, one of the things that we have learned with our customers is what people do, and we've made these mistakes ourselves, is you start the first project, it's usually a proof of concept. You don't think about subscription, account, workspaces. You go create your workspace, you start writing code. You're either successful, you hit an issue, you solve it, and then you become successful. And then at least what we hear is people are blown away, and then they start scaling up. This leads to a lot of problems. Trying to plan your hierarchy in the beginning is very, very important. Here are a couple of things that customers ask us that are pain points for them. This is more on the administration side. They had one team start this project. They had one workspace, and the team liked it. They spread it around. Now they have 200 workspaces. The IT people don't know how to build each of the individual customers. Some might be from finance. Some might be from HR. Some might be from other development areas. So planning this hierarchy is very, very critical in the beginning, and it helps you out in the long run. One of the models we recommend, and all of these are documented, we'll share links for everything, all of these are documented, is sort of this business division model where you have an enterprise, and at the bottom, your applications are running on subscriptions. And having a clear idea of this is very important because you want to know where you want to go, not where you are today. And that's going to help you out. I said the cloud, we have infinite limits. You can scale to infinite capacity, but turns out we do have some limits, and I'll talk about these limits and why we have them. So our workspaces have certain limits, And Azure subscriptions have certain limits. And when customers started, nobody ever hit these limits. Like nobody was running these many VMs in a region. Like nobody's running 25,000 VMs in one subscription in a region. But where we are right now with Azure Databricks, there are plenty of customers who started to hit this. These limits exist because we want to protect, we are a multi-tenant cloud. We want to protect the neighbor from a different person who might be abusing the system. So there are a lot of good reasons for why these limits exist. All of these are documented, and we're continuously trying to improve them. There are two things we're trying to do. We're trying to centralize all of the documented limits so you don't hit them or you can plan for them, and we're continuously trying to optimize to increase them. So do talk to us if you start to hit them, but these are certain things that are very, very important because once your solution is built, it is incredibly hard. We have gone through some very painful scenarios with our customers to make them successful in resolving some of these limits. VNet, how many people heard that we released VNet injection? How many people care about VNet injection? So when we launched, this is one of the things that I made the decision, clearly turned out to be a poor decision. When we launched this service, we would deploy the clusters in a VNet that we create for you and that we manage for you. And it was my idea that this goes with our theme of making you much more productive and you don't have to manage a VNet. I very quickly learned in 2 months that that was a really bad idea. Nobody liked that idea. Every IT department hated me. They all called me and said, we're not going to use this. So we've been working on this feature called VNet injection, where you can deploy in your own VNet. And now you're able to do that. So you can configure your own VNet, you can deploy your own VNet. What we recommend, what we've seen people do, again, this is a scaling challenge. When people start out, they have one workspace and they deploy it in one VNet, and maybe they have 2 workspaces in one VNet, and that works fine. But when that becomes 300 workspaces, all sorts of challenges start to exist because you want to have different policies maybe for different people, and you want to have defense and depth differently for different people, and that becomes hard to manage. So we recommend that isolating each workspace in one limit. This is more of a soft recommendation. What we are trying to tell you is think about this more than anything else, because not thinking about this creates problems. The other challenge with VNet, I shouldn't say challenge, the other opportunity with VNet is setting CIDR ranges. This is a fun one. We use CIDR ranges to determine the size of the subnets. And again, people choose super small CIDR ranges in the beginning because they believe that they're going to use a 10-node cluster, and then they forget about it, and then they eventually end up having a 100-node cluster or multiple 100-node clusters, and they start hitting all sorts of issues. So the network planning on how many addresses you assign is very, very critical. Like, if you were to take away one thing from the networking section, I would take this one away. We've done some math here for you, and we also have all of this documented, but you typically need 5 addresses, a range of 5 addresses per node you're going to have. So if you're going to have, let's say, a 100-node cluster, how big should the range be? Nobody? 500, yes. So we have this little table. I'm sure all of you guys know how CIDR ranges are calculated, but it shows you sort of, if you do a /22 and you're trying to have a 100-node cluster, that's clearly not going to work out. And these problems are hard to detect, and what happens is when some customers hit these problems, this is how it comes back to us. It's unlikely that the IT admin who set up the VNet hits this problem. It's the developer who scales up the cluster hits this problem. They may or may not know about how the VNet was set up. So there is a long time of productivity loss, which is why these are some of the guidelines that we provide. The other one, this one is also interesting. How many people know what DBFS is? How many people have accidentally or deliberately stored data in the default DBFS location? All right, I see a couple, so at least it's a value. So absolutely don't do this. DBFS is a mechanism that we use. It's file system technology that we use. We provide a storage account. That storage account is used for saving scripts and internal stuff that you use on your own account. This is absolutely not recommended to store your customer data. When you store customer data, you want to own the account. This account is managed by us, so you don't want to put your data in our account. You want to put your data in your account, which has your keys and is able to connect through our system. So again, what happens here is people start storing data. Small experiments, the experiments grow big, they go into production. I get a call that your system is not secure because you don't let me manage the keys. So we're trying to build in these best practices. We're also trying to make some changes to the product so these things show up more visibly. So I would definitely not do that. This one, I think I was talking to somebody about this one, but very simple, store secrets in key vaults. There are a number of times in Databricks, whether you're writing a job or you're starting up a cluster or you're building a notebook, you're going to connect to something else. This is the most common place where secrets are used. So let's say you're connecting to a SQL data warehouse. You're likely going to have a connection string that includes some secret information. Let's say you were connecting to blob storage. You're going to have a SAS token that is clearly secret information. And you don't want to put these pieces of information in the notebook on the clear. We have built-in technology on how to store this using something called secret scopes in Key Vault. And we are also continuously trying to improve that and build more and more enhancements as we get requests. But we do have enough today that you don't need to store them in the clear. So please absolutely don't do that, because somebody is going to scan your system at some point of time and say that you're using a service where you're storing secrets that can be seen by anybody. So with that, we're going to shift gears a little bit. I'm going to see how I'm doing on time. It looks like we have time. From the IT side to the more harder side, developers, like what are developers looking for? Here are some common questions they ask. What type of clusters should I use? Because if you read through our documentation, you're going to see that there are different kinds of clusters, and they have different prices and different attributes. Which cluster should I use? How many drivers and how many workers? How many should I put? And the most interesting one is which Azure VM should I select? If you've gone and created a cluster, I do this every day. That drop-down keeps on increasing. There's so many options, and which one should I select? So this section is more going to be guidelines. There are going to be a lot of developers who know much better than what I am going to say. So these are overall broad guidelines on how you should do things. So we'll start out with a little bit about cluster modes and characteristics of these modes. So our clusters operate in two modes. There is a standard mode, and there is a high concurrency mode. And this is a choice you get when you go to create a cluster. You will have a drop-down with these choices. And these are very, very different cluster types that have very different intentions. Sorry, I'm having a hard time reading from there, so I'm going to stand here for a while. But one of them is targeted towards data engineers or people who are running jobs. The other one is targeted towards interactive users. There is language differences. Because of our high concurrency cluster allows for multiple users and user isolation. We don't yet support Scala and Java in that cluster. The security models are very different. One of them is designed for a single user. The other one is, of course, designed for multi-user. I spoke about isolation a little bit. Some of these features that are very interesting in interactive scenarios, such as table-level security, pass-through, query preemption, like fair scheduling of the queries, so that even though one guy might have had a really big query, we still let everybody in. That's possible in high concurrency clusters. So it's very important, like your workload and your SLA, like when your workloads become production and you want SLAs, these choices are going to have a big difference, a big impact on what you can commit upstream to your customers who you're delivering the solution to. So those are the cluster types. We also want to think about workloads a little bit. We think workloads can broadly be defined as interactive and batch. There is also a real-time workload, but for purposes of this conversation, the two big things are interactive and batch. Interactive is when you have users actively using our product, most likely through our user interface, maybe through an IDE. We broadly consider that as an interactive workload. A batch workload is something that's running either constantly or periodically, has pretty fixed size, doesn't go through that many changes, at least not on a daily basis. It might rev once a week. That's a batch workload. And the optimization metrics are very, very different. For an interactive workload, what users have told us is that they want low latency, like they want the queries to come back quickly. While for batch workloads, the latency doesn't matter that much, but it's the throughput that counts for them. Submission patterns, obviously, interactive is manual submission. You write a line of code in the notebook, or you execute the entire notebook or multiple chain notebooks together. That's the interactive mode. And in the batch mode, you're automatically submitting it. Most job queries, and we'll give you a little tip in the next or the 2 slides later, where most of your submissions should come through an ADF or a job submission tool, NiFi, or our built-in job scheduler, because that saves you a lot of money versus starting a cluster and submitting a job to it. Costs, you want predictable on batch workloads because you're going to be running this every time. This generates meters. Interactive, you're a little bit more flexible. Maybe you want to put a threshold on how much your engineers can spend on the total. So for interactive workloads, what we recommend is always to use the shared high concurrency cluster. The one easy thing you can do as an administrator is you can limit the cost. You can say that this high concurrency cluster can only scale up, and we always auto-scale up and down, but you can set the limit that it can only scale up to, let's say, 50 nodes or 100 nodes. So you know you have predictable cost models where you know what the threshold limits are. They are optimized for latency. We won't go into the details of the algorithm, but when 12 users or 20 users are using the same cluster, it is very easy for one user to take over the entire cluster by writing a bad query. So we have scheduling algorithms built in only in the high concurrency cluster to avoid this and to make sure that everybody gets fair share scheduling. And we continue to enhance that algorithm every time. And then there's security. One of the problems with multiple users using the same cluster is you want isolation of processes. Right? If you crash the R process, you don't want to crash it for everybody. So we have isolation built in at different levels. There's process isolation, but there is also isolation of ACLs. So let's say you're using table-level ACLs. You only get access to the data that you have authenticated access to. For batch workloads, we support standard clusters, or we recommend standard clusters. They have predictable SLAs. They have predictable SLAs if you use them in the manner that they are intended. One cluster, you can submit multiple jobs, but they're going to be executed one after the other. But only one user is submitting these jobs. That can be a system user, a human user, doesn't really matter. But they are predictable SLAs you can generate. And the cost is lower. How many people know this, that a cluster that is started using an API, a jobs cluster is started using a job submission API is much cheaper than the exact same cluster if it was starting using the UI. Anybody knew that? So we're clearly doing a bad job at messaging that, but there is a big price difference. I won't call out the price here because everybody might have a different currency, but you guys should go and look up a job cluster and an interactive cluster, and they're going to have different pricing. And so for jobs, we recommend that you optimize and try to use our job submission APIs to start and stop those clusters. Unless you have a need to use the interactive clusters, I would recommend you do it that way for your regular running, long-running batch ETL jobs. Initialization scripts. We have spent a ton of time. I think Premal's here, and Premal's the guy who's from my team who spends time on initialization scripts. People create global initialization scripts. A global initialization script in a workspace is something that applies to every one of the clusters that are ever started from there on. Again, these are growing pain problems. The first person comes in, he creates a global init script because he wants to take care of the problem. And after that, there are hundreds of users who create 50 of clusters. All of those clusters run that initialization script. Problems that we see initialization script is going and downloading a file from an IP address that maybe is on their corp. That IP address changes, all clusters fail. This is, again, when I say it, it might sound like, oh, that's not a novel idea. That seems pretty straightforward. But the number of failures that we see, the huge amount of productivity loss that we see by people creating these global init scripts. We have them there for a reason. We are working hard to see how we can provide differentiated tools because we have built-in global init script capabilities. They serve some purposes, but most of the time, like 9 out of 10 times, what we see is they're accidentally used and then cause all sorts of problems. So cluster creation issues, this is not the top, but maybe in the top 6 of the cluster creation issues. So create local init scripts, make sure they're in the configuration. We're going to continue, again, to enhance this. The other choice, one of the choices that the developer has to make, which VM to pick. We have D series, L series, F series, NC, and we're going to keep adding more. Azure Databricks does not support all of the Azure VMs. That's for a reason, because some of them are not powerful enough to run our application. So we support the ones that we think are appropriate. But you have all of these options, and you have all of these workloads, machine learning, streaming, ETL, interactive, which one to use. you have to sort of use some gauges in here, like a streaming workload. A streaming workload, typically you want to make sure is compute optimized because it's continuously computing something or the other, and you don't want the inbound stream to be bigger than your CPU capacity. So that would be something to think about. An ETL workload, typically general purpose, machine learning workload, you might want to use GPU depending upon what kind of machine learning you're doing. You want to make sure that if you're doing a lot of memory calculations, then it's a memory optimized machine. Again, sounds pretty obvious, sounds pretty simple, but the number of questions that we get on this and the number of customers who ask us these things has led us to at least reintroduce these basic concepts. After you follow all of the patterns and practices, there are still going to be problems. People are going to run into issues. Here's my quick sheet solution. Figure out one of these three things. I'm talking about a developer problem. You are going to figure out that you're CPU bound, you're network bound, or you're disk IO bound. These are the most common categories of problems. If you are CPU bound, the quick fix, not the permanent fix, but the quick fix is add more cores. So increase the size of your cluster. If you're CPU bound, or choose a bigger machine that has more cores. If you are network bound, you are doing a lot of shuffles likely. That's why you're getting network bound. Try to have machines that have fewer but bigger SSDs. And you can look up all of this information, and that's going to solve some of your network bound issues. If you're disk IO bound, again, use VMs with more memory. But these are the common problems that people run into, and these are the first suggestions that we give. One more thing, the last one before I leave, and I promise this is the last one, is partition the data. A lot of people don't come from a big data background. A lot of people are not partitioning the data, but we absolutely recommend that you, in most cases, partition, but don't over-partition your data, because that causes a different kind of problem. There's some guidelines. I'm not going to read each one of them. You're all going to get linked to the document where this is stored that we are building, continuously improving, but please do think about partitioning schemes. So sort of recapping today, plan your hierarchy, understand quotas and limits. This is just the reality of these systems. Like no matter what anybody else says, which cloud you are on, this is something you should always take into mind, especially with a solution like Azure Databricks, because you're going to scale from small to very, very big very quickly. At least a lot of our customers are doing that. It's not a problem if you're running 1,000 VMs. It's a problem when you're running 25,000 VMs. That's when you need to plan better. And we've seen a lot of customers get there. Build a plan for the network. Know what you're getting into. Document some of these things so when you run into issues, you know why you made those choices and what those choices were. Don't persist data in our storage. Use the appropriate cluster. That's the cost-saving tip of the day. Like I would like for everybody who's using batch ETL to go look at that job cluster. If you're not using it, please use it, or tell us if there's a reason you can't use it. But that's going to save you incredible amount of money. That's going to bring your TCO come down a lot. And partition the data. That's what I have for today. But this is the beginning of a journey. I don't want this, like usually I give talks about Databricks where I'm disseminating information and I'm looking for people to take that information and do something with it, hopefully something valuable. But this is the beginning of a journey. We've built these best practices working with the customers who are going through the most excruciating pain. So please do work with us. We would love to hear from you. There are several ways to reach out to us. If you're specifically interested in best practices, participate in our GitHub page. If you have a problem, I was telling the gentleman over there, if you have a problem, please, in excruciating details, put it in the support ticket. It might not appear, but we all review 50 support tickets. Every one person on the team has to review at least 50 support tickets every month. That's how we improve our product. So please do put excruciating details. We read all of them. We don't reply back to you, because if we reply back to you, then you'll start reaching out to us, and the whole system fails. We cannot scale the product team to that scale. So again, it's beginning time. Let's start this journey. If we do it collaboratively, it's going to be 10x faster, maybe 100x faster, depending upon the number of people who participate. So this is our roadmap. I'll leave this on there. I'll take questions. If anybody has any questions, if you could use the mic, that would be great. Otherwise, I would have to repeat your question.
You mentioned about the two patterns of use case, right? The interactive user, where you use the high concurrency clusters, and the batch, where you will have single cluster. What if we have batch, but we have a situation of multiple instances of jobs triggers concurrently? You know,
So I would have to understand that a little bit more in detail, but by default, I would say if you have multiple jobs, why couldn't you start a cluster for each job?
yeah. So that can be done, right? Like
Depending, if you're working on the same data and there is a sequence need, then they might have to be one after the other. Otherwise, you can concurrently start.
these are different data, different.
Yeah, then I would definitely do one job, like one particular solution on one cluster. What you got to think about there, the important thing to note over there is what is the overhead time for you. If you have 1 million jobs that are all 1 minute each, and you're starting a new cluster, you're paying an overhead, or at least your SLA is going to pay an overhead of 5 minutes because that's how long it takes to start a cluster. We have something called pools that we just introduced. It should be up there. That solves that problem, that keeps a VM hot for you. So clusters can start in like 80, 90 seconds. But by default, let's say your jobs were 15 minutes each, I would do one job per one cluster.
Okay, thank you.
So thank you. We just started using Databricks about 3 months ago. One of the common questions I'm getting from my data scientists is, do you have a matrix that will show what libraries are supported on different clusters? For example, you just came up with the Conda cluster, which was of help to us. But they want to know what features are supported across the different types of clusters. Machine learning, GPU, that sort of thing.
So I don't know if we have that on our documented page yet, but if we don't, we will get you that information. Is there, like we will get it for everybody, but is there, would you mind sharing your contact information with one of my colleagues there? And we'll get you that information.
Question, please.
No other questions?
I have a question, please.
So, sorry, please.
I think this is probably the question that people ask you the most. We evaluating the Spark platform. Can you comment on the difference between the Spark offer in the Synapse and the Spark offer in the Databricks, and any kind of differentiation between the two?
That's a great question. So the question's about, and I think several other people had this question. The question was very specific about the Spark offering in Synapse that was announced here at Ignite and Azure Databricks. The way we think about it is, it's not about comparing what Spark is doing here and what Spark is doing there. It's about building solutions, and depending upon your solution need, if you are building a solution where you are going to use Data Warehouse, where you are going to use Data Factory, where you are going to use Power BI, and you're starting fresh, you're not already using Databricks, you want all of that in a small package where it's easier to manage, then you would go with Synapse. If you're doing Spark-heavy workloads, or if you're already a Databricks user, you want to use it on multiple clouds, you would use Azure Databricks. From a feature comparison, like I get the very specific question of, hey, give me a table that says left-hand side can do X, Y, Z, and right-hand side can do A, B, C. And we've thought about that a lot. And that is just incredibly hard for us to produce because both of these services have a robust roadmap. Like you look at our list, Synapse team has a list. We are all actually part of the same larger team. They have a list, and so both of them are constantly pushing the envelope and delivering to customers. So that one's harder. We should have something maybe for you towards the GA of Synapse Spark. Maybe at that time we can take a snapshot of the features, but we're continuously pushing the envelope on the most requested features for both of these audiences. No more questions? I see one more.
We have a group using the Azure Databricks for almost,
sorry, sir, I can't hear.
Almost a year, and we are wondering the integration between the Azure Databricks and Azure DevOps, because we still have some. I think it's still something that's missing in the Azure DevOps for the complete CI/CD.
So we can take that question offline and get some more specifics. You're doing Git, I presume, for complete CI/CD? So there is some ongoing developments. Let us talk to you offline for this meeting, and we'll help you out, or either tell you it's coming, or we're going to work on it, or if we're not going to work on it. That's all I had today. Hope you enjoyed the 45 minutes. Thank you guys very much for your time. Really appreciate it.